Okay, welcome back, guys. Today I'm pre-recording this lesson because there's quite a few big ideas. We're looking at matrix arithmetic and we're looking at the product of two matrices. Now, to get the product, you need to multiply. So first thing you need to know is when two matrices can be multiplied, and then you need to worry about how to do it. And of course, then you've got to apply it to some worded questions. So first thing you need to do is know whether two matrices are defined or not defined. We'll go through that. Identify the order that would result if you multiplied two matrices, and by the order I mean the matrix that's produced. Be able to do it on your CAS calculator. Be able to represent simultaneous equations using matrices, and apply something called summing matrices to sum rows or columns. It means to add them up really quickly, and to apply these ideas to your worded questions. And there's your exercises. Now, when you look on Sector, you will see there's two documents there. I'll be referring to those two documents throughout. Okay, so we'll use the Word document as our primary source today, and occasionally I'll refer to the PDF. So, the product of two matrices, the conditions that must be met when you're multiplying two matrices is that when you write out the orders, remember it's rows by columns and rows by columns, the columns of the first matrix must be the same as the row of the second matrix. That's a condition that must be followed. Now, if these two numbers aren't the same, where n is written, it means you can't multiply these two matrices together. When you do this, you will find that the rows of the first matrix and the column of the second matrix will give you your answer matrix. So that's a way to predict what your matrix should look like and will help you with self-correcting. One thing that this worksheet doesn't have that I would like to add is when you meet this stipulation, you can say that they're defined. Okay, if they can be multiplied, they're defined. If they can't be multiplied, they're not defined. Okay, so make sure you are aware of that definition. So that's the first two dot points of our success criteria, knowing when matrices can be multiplied, when the first columns and the second rows match, and that the resulting matrix will have the order m times p, where m is the rows of the first matrix and p is the columns of the second matrix. Now on this worksheet, we get you to multiply matrices using your CAS. You can do it by hand, but it's kind of a long process. And if you are interested in knowing how, you can of course refer to your textbook, and you can also refer to this document here, which shows you step by step how to do it. Okay, but I don't believe you need to know how to do it by hand for the VCE exam. Okay, let's have a look at an application so we can make sense out of this statement here, where that the resulting matrix will have the following labels. So I'm talking about across the top of the rows and the columns. So the first matrix will keep its row labels. So in this case, this is the first matrix. So it's going to be George and Anthony. And the second matrix will keep its column labels. Now, we've been given an example where we've got George and Anthony and they're at a football match, and this is what they kicked. So George kicked 6 goals and 8 behinds. Anthony isn't so accurate. He kicked 4 goals and 12 behinds. Now, for those who don't know football, each goal is worth 6 points and each behind is worth 1 point. So to do the second matrix, we're going to have to set it up like this. Okay, so it's going to be the points value. And it's going to be a column matrix because goals are worth 1 and behinds are worth 6. So I'm just going to write G for goals and B for behinds. Now what we're going to want to do is we're going to want to multiply these two matrices. First thing we have to do is make sure that the orders are defined. So the order of the first one is It's a 2 by 2. And the order of the second matrix is it's got 2 rows and 1 column. So when we look at these two numbers, we see that they're the same, so we can multiply it. When we look at the outside numbers, which is 2 and 1, that'll tell us the order of the new matrix. So the new matrix is going to be 2 rows and 1 column, because it'll be 2.1. One thing I forgot to include was a column header. So this will be the points that a goal is worth 6 and a behind is worth 1. Okay, just to highlight this concept here, the first matrix keeps its row labels. Now the first matrix had the names George and Anthony, so I've just rewritten them there. And the second matrix will keep its column label. Now the column label was just points, so I've just written points on top. So when I work it out, George kicked 6 goals, so that's 6 times 6, plus 8 behind, so that's 8 times 1. Anthony kicked 4 goals, so it's 4 times 6, plus 12 behinds, which is 12 times 1. So the final answer is going to be George, Anthony, and George got 6 times 6 is 36, plus 8 times 1 is 8, so that's 42. Anthony got 24, 4 times 6 plus 12 is 36. Okay, that's the points that each player earned. I'll quickly show you how to do that on the calculator. Okay, so we're on a calculator screen. The first thing I need is a 2 by 2 matrix. There's one pre-made there. So I'm just going to say that, hit enter. There it is. The values that I'm entering are 4, 8, no, hang on, wasn't it 6? Pardon me. 6, 8, and then it was 4 and 12. And we're going to multiply that by, oops, a daisy. Hit that button again. We're looking for a column matrix of 2 this time. It's a pre-made, so we're just going to select that. And it was 6 points for a goal and 1 point for a behind. We hit enter, and we can see we get the same answer there. Okay, so that's how you use it on the CAS. And you can see that that's George's, that's Anthony's, and that these are the total points that they've earned. So again, even though I'm showing you how to do it by hand in some of the questions, you can always just go straight to your CAS. Sometimes you get these things called summing matrices. Now, this is when you've either got a row or a column matrix and all the elements are 1. So these two are examples of column summing matrices, and these two are examples of row summing matrices. Okay, and what they used to do is to add up what's in a matrix quickly for you. So the rules are, if you want to sum or add up the rows of a matrix, post-multiply the matrix by using an n times 1 summing matrix. So 1 is the column, so using a column matrix with only 1s in it. Post-multiply means do it afterwards. If you want to sum the columns of an m times n matrix, pre-multiply it using a row matrix. So I might add that detail there for you. So this one is a column, summing matrix. And this one's a row summing matrix. And pre means before and post means behind. We'll look at that in an example later on in a bit more detail. Let's go on to simultaneous equations. Right, let's have a look at this. This is some big ideas in this one. So here you've got a couple of simultaneous equations. Ax plus by equals E and Cx plus dy equals F. Now you've got to turn it into 3 matrices where A, B, C, D, E, and F are all numbers, but X and Y are coordinates. And you're going to use this setup where it's A times X equals B. First, I'm going to look at A. Now, A is made up of the coefficients from the two equations. In case you don't remember what a coefficient is, it's a letter that accompanies the variables. Now, the variables are x and y because they can change, but that means that A, B, C, and D are coefficients. So that's why they make up this first matrix. You can see them here, A, B, C, D. That means that x and y, which I've highlighted in blue, go into our second matrix here. And that is, of course, what we call in algebra our variables. So they're present in, well, not necessarily every equation, but they're present, but you need to realize that those values can change. They're not set like the coefficients are. And they are here. That's that middle matrix. And finally, the answers, which I'll give a different color, I'll give them green, make up B. Okay, so this is what the product of each equation is. And that goes after the equals in the final matrix. Okay, let's use that for some examples. So we have to determine which of the following products are defined and write the order of the resulting matrix if they are defined. So we're looking for ones that fit the first requirement where the columns of the first matrix and the rows of the second matrix are the same. So let's have a look at the first one. We've got A. Let me pick a decent pen color. A, the order of A is 2 rows by 3 columns. And B is 2 by 2. Okay, so rows by columns, rows by columns. We can see that these two here, the numbers aren't the same, so we can't go forward with them. We say it's not defined. If we look at BA, that means we're doing 2 by 2 and 2 by 3. These two work, so they're defined, and the product, the matrix, would have the order of 2 by 3 because 2 by 3. C and B. C, we've got a column matrix, so it's 3 rows by 1 column, and B was 2 by 2, so that's no good, that's not defined. And A by C, we've got 2 by 3 and 3 by 1. Yep, that works. And you can see we've got 2 by 1 left outside, so the product would have the order of 2 by 1. Okay, we've got Ben and Daniel. They're selling carrots and onions. Carrots sell for $4, onions sell for $6. Let's see who will make the most money. So the product matrix is going to have Ben and Daniel, which are the rows, as the headers, and it's going to have dollars as the column header. Now to work out Ben, he's got 12 carrots. That's 12 times 4 plus 8 times 6 onions. Daniel has 9 times 4 plus 14 times the 6 onions, which gives 48 plus 48 is 96, and 36 plus 84 is 120. And of course you can do it on your CAS, and I've added what it should look like on the CAS there. Okay, next example. Write the following simultaneous equations as matrices, remembering we're using A, which is the coefficients, as one matrix. We're using X, and then that's going to equal B, which is basically the answers. So A is going to be 5, 2, 7, 3. The middle matrix is just going to be X and Y because that's our coefficients. And the last matrix is going to be the answers, which is 21 and 29. Done. Okay, in the last example, we're going to use some summing matrices, but I have to stop these videos after 15 minutes. So I'll pause this one, upload it, and then start again.